Hello guys, today I am back with another video where I will be showing you a project that allows you to question question any particular document that you have and get answers from DeepSeek R1 for your particular documents. So this project will focus on RAG technology, that is Retrieval-Augmented Generation. This will allow you to use your LLM on your custom data set, I must say, and then get the best answers out of your LLM. So let's go ahead and see this project first before we understand the code and how you will be implementing this project. So first of all, you will be uploading your document. So I am using Attention is All You Need research paper. It's a famous research on transformers that literally changed the world of LLM. You must get through it. So I've uploaded the document. It is taking some time to upload, as you can see. So just let's give it as some time. So we will see the document has processed successfully. It has uploaded, it has been uploaded, and then it has been stored in our vector database, which I will be going through later onwards. And then now we can ask any question about this document. So first let me go ask Sarah, summarize the research. Let's research paper in simple terms. So let's go ahead and see what our DeepSeek R1 model will generate for this particular question. It must be going through the document, and then we'll see the answer soon. I think due to some connectivity issues, it is taking time, but yeah. Yeah, so we got our response. I don't know which specific research paper you are referring to. The context provided this month. Okay, so we can say DeepSeek has not given us a proper answer. Summarize the document, let's say. Let's see what will be the answer for here. Let us see what the DeepSeek LLM will answer here. We can obviously use other LLMs here also. It's not only limited to DeepSeek. So let's see the response here. The document is a list of references covering various topics in NLP and machine learning, key themes in abstracting, summarizing, language modeling, neural machine translation, data handling, rare words, dropout for preventing. So yeah, you can see it gave a pretty good answer. So of course we can later fine tune this model for better responses, or use a different model, different open source model like Llama, Mistral, anything else. So for the purpose of this project, I am using DeepSeek. I will however show you how you can use other various LLM and try what works best for you. So so before going into the code, let me show you what RAG is, and let's just go through over it quickly. So I found a pretty good article in LinkedIn from Pradeep Menon. I will share the link in the description below. So you can see how a user will send its query to a particular interface. For us, we are using here Streamlit. So it will then process the query and then turn it into some embeddings. So later that embeddings which we have trained from our model, we can be using that also. If not, we can directly proceed with that embeddings and provide it to LLM for a better answer and generation of generations, and that will be shown to the user afterward. So let's go ahead and check the code now. You can go ahead and go through this article. You'll get various good insight about this technology. You can see there are various types also. So yes, you can go through this for your research purpose. So let's go ahead and take a look at the code. So you can you can take a look at this code. We'll be having two files, main.py and utility.py. You can however run this in a single code file as well, but for the purpose of modularity, I've been using two different code. So you can see first you'll need to, like for any other Python project, you'll be first initializing your environment, and after that you'll be installing the necessary libraries that are required here. So we will be using LangChain, Groq, Streamlit, and DeepSeek R1 for this project. So Streamlit will be used for the UI purpose, and then Groq will be used for it's an inference that allows us to use DeepSeek R1. And then we will be using LangChain for reading the PDF files, and then we will be storing them into Chroma DB. We'll be using Hugging Face for the embeddings, and then we'll be storing them into Chroma DB. So first thing first, so when you're using Streamlit, you will have to go through the documentations and then design a simple layout. So we're setting the page configuration first, like you can see the page and the page name and centered like your document. So and then you can make a sidebar using st.sidebar header, and then you can prompt the user to upload their PDF file there. You go ahead and save this particular document in your working directory, and after that the user will be sending their question, and once the user has sent the question, will be answering the question using our LLM, using this answer question function, which will be in the utility.py. And also when you save in our file and then we process it to embeddings, we're processing the document using process document to Chroma DB function, which will be in utility.py. I will show you that ahead. So basically from utility.py we're importing two other functions which we will look, and then we are using those two main functions to run our RAG in Streamlit. So the other two functions what we are using over here is process document to Chroma DB and answer question. So like again we'll be importing our necessary libraries, LangChain unstructured PDF loader, recursive character text splitter to split our PDF into chunks so that we can easily turn them into embeddings. So we'll be using Hugging Face for embeddings. Embeddings will basically convert our PDF files into now numerical representations that can later be used by LLM models to retrieve the answer. Then we'll be using Chroma DB to save our embeddings. It's called vector database, so we'll be storing our embeddings over there, and then we'll be using Groq, chat Groq. I will be showing you about Groq later onwards. So Groq is basically a inference that allows you to use all these LLMs with faster recalls. So you can directly use the LLM or you can use an inference Groq. So first thing first, we'll need to obtain an API fee from Groq. I will be showing you that in a while. Also, I have shown this in previous video. You should check that out also. So you will be importing the Groq API key from .env file. So it's good practice to use .env file to retrieve your Groq API key instead of hard coding it. And then we'll be loading our embeddings, Hugging Face embeddings into embeddings, and then once after that we'll be calling our LLM model using chat Groq. You can get all this code documentations from the respective websites as well, or just a small research will help you understand. It's not that complicated. We're calling our model DeepSeek R1 Distill Llama 70 billion parameters 1, temperature 0. And then after that there is a function we have called here, like I told you before, we have declared here, like I said you before, process document to Chroma DB. So what this does is it takes our document, it loads it using unstructured PDF loader, and then we split the documents into chunks. So the chunk size here is 200. You can obviously 2000. You can always play around this using recursive character text splitter. Once that is done, we'll be taking those chunks and then turning it into an embedding, vector embedding, and store it into this our directory doc vector store. Once that is done, this will help us to turn our document into embeddings and store it into our vector database. Once that is done, I will be declaring another function called answer question. This allows us to allow our LLM to interact with our vector database to answer a particular user question using retriever, and then this retrieves the answer and gives us the result into which is shown to the user. So this is it. This is a simple project. This is all basically that is. So you can see some yellow lines here. Obviously I'm having some issues with the environment here, but however I can see it's running. Do let me know if you know why this must be happening. So it's running, so I didn't really bother to take it right now. So Let me go ahead and show you and run this code again. So we'll be deleting this vector database. So I will show you it's getting recreated, and then I'll be deleting this document as well. This is the one that we uploaded earlier. So let's go ahead and run this. So whenever you run a Streamlit program, you run it through this command, Streamlit run main.py. Like you do python app.py, for Streamlit you will be using this particular command. So once you do that, it will redirect you to your browser. You can see the old one is here running. So I've run it again, so you'll see it will load up here. We can go ahead and close this one. The link to this LinkedIn post will be in the description below. Do go through it. You'll have a better understanding of the technology. Yeah, so let's go ahead again. Browse files will be sorry, okay, I deleted the document, so we can go ahead and we'll upload another document called this Python ML guide. I think it's a document. I'll just show it to you. Okay, never mind, we were not finding it. Yeah, so we can see the document has been processed below. Let's say what is the document about. Let's see, this is an unseen document for myself also. So let's go ahead and see what our DeepSeek has answered. The document is a guide to essential Python libraries, frameworks used in machine learning. It covers key tools like NumPy for numerical computing, pandas. I'm pretty sure it is this document only. So yeah, you can see the code is working. We have the vector database that is stored over here, and then we can see the document got uploaded to your project directory. So yeah, this is the basic version of Retrieval-Augmented Generation project. So however, you can go ahead and make this project more better by adding a composed pipeline, and then you can add good database sources over here and train your the vector database on that, and then use it for a particular purpose as well. So the possibilities are endless. I hope you like the project. Without further ado, I'll be taking your leave. Thank you.